All right, so 10-3, we are simplifying, combining algebraic expressions just through addition. So the first thing we have here, we have the twins. And this kind of reminds me, for Discovery Day, I think we're full, but how many people have volunteered to go to Ronald McDonald House? I'm going. Nice. We'll see that. How Cabins is going to be sweet, too. I was debating which one to do. All right, sweet. We have 15 going to the Ronald McDonald House, actually. So when we look up here at the twins have gathered up donations of food and money. And we want to write an expression to represent the total that they've gathered. Question? Oh, well, Rye, thanks. I thought you guys just took care of that as soon as you came in because you're responsible young adults. So it doesn't matter. This is not on your notes. So while Rye passes those out. So if you were working with the twins and you wanted to express everything you got from that donation round, would you say we've got 1 corn plus 1 peas plus 1 corn plus $5 plus $5 plus $5? Like, what would you do, Shahib? So you'd organize, right? So we would regroup or reorder. Let's drag all our money over here. Let's put the corn over here, magical floating corn. So we got corn, corn, more corn, even more corn. People love corn. We've got some boxes of rice. And we've got some peas. And then some money of different amounts. So now we've organized. So now how do you think I can write out an expression to represent what we've had donated? Baylor?
5 cans of corn plus 2.
Now wait, so am I going to write the whole 5 cans of corn?
No, just write 5.
5 what?
5 and then maybe a unit rate that's 5.
Well, do you know what a can of corn is worth?
No.
We don't, do we? Karen?
5C.
Ah, we use variables. So we can say 5C plus 2R plus 3P. Yeah, do you know how much money's worth? Yeah, it's worth what it is worth. It is printed on it. So you've got 5, 10, 30, 50, 60, 5, and 50 cents. So that's how we could write an expression for all of the donations from that round. Does that make sense?
Makes dollars.
Ha ha.
Never gets old.
I might beg to differ.
You might?
Might possibly.
I'll wait.
So, we want to identify what makes up a variable term, what makes up a constant term, and what makes a coefficient. Now, a variable term. Who thinks they can define what a variable term is?
I need a new one because.
You need a new one. What? Here, I'll trade you. Cross this out. Change the. Well, was there an extra over there? Because there may or may not.
No, there's.
Is there an extra there? Because this is the same as the Math 7 notes today. Why do we use variables? Like just to make it fun. Math's better with numbers and letters combined. Olivia?
I'm just guessing, but because sometimes we don't always know the thing.
The thing?
Yeah.
What? So let's be a little bit more mathematical than thing. What would we not know? We use variables to express what?
The value.
Value. So a variable is an unknown value that we express with what? Sheep? With letters. So an unknown value expressed, and it could actually be symbols too, but we'll make life easy and just say expressed with letters. And you could put or symbols if you want to be real particular. Because you could have like 4 smiley faces plus 3 thumbs up plus 2 winks Like it doesn't like you could use anything as variables. You could say you have 3 purple and 2 red, and like anything can be variables. Actually, I might make that as an exemplary project. Make your own mathematical values. I'll have to think that up. What about a constant term? Why? Like, what does it mean to be constant? Leah?
It
Doesn't change. So it's a fixed value that we know. Coefficient is a very fun word to spell. Coefficient. Coefficient. Got those 2 I's in there.
Well, it's efficient.
I know. But I like to say coefficient. Pronounce the extra I. Shahid?
A coefficient is a number that is placed with a variable.
But why? What does it do?
It's telling like how much of that unknown value there is.
Okay, so mathematically, what does it do to that variable? So when we have like the value 3x. Yeah. So a coefficient is a multiplier, P-L-I-E-R, to a variable. Commonly, it's in front, or we can just say in front. Placed directly in front. My Y got a little weird there. Apologies. Pranav?
I don't know if this is like logically correct, but could you have a number that says like 3 for x 5?
That'd be 34x times 5. So then that'd be 170.
No, would
X.
it be like which one would we do? Like the 34 and the x, or could we do the x and the other?
What you just described is a string of multiplication. So multiplication order is irrelevant. We could do it in any order we want to.
Okay.
Yeah. So you have your example here. Now, one of the things that you're going to do, and you're going to like start your homework thinking, why is this so easy? It's going to ask you how many terms are there in an expression. Big thing is to identify if you have like terms, they have to be combined before you can determine that that is a term. So here we have an x term, a y term, and a constant term. 3 terms. Some people try to only count variables as terms. Constants count as a term also. Then my coefficients, I have to list all of them. So I have a -5 here. What coefficient is actually in front of the y?
1.
Carrie? 1. Why don't we write it? Yeah, it's the same with or without it. So we don't have to say 1y, but we can. So I have a coefficient of -5, and I have a coefficient of 1, and then I have a constant of 2. I just captured the same thing again. So, because addition and subtraction are essentially the same thing, they just do the inverse of each other, we can always write a subtraction as the addition of a negative, and here's why you at least want to think about this. Your coefficient, here, if I gave you this expression, people would try to say, oh, there's a coefficient of -1, and then there's a coefficient of 2.5. That's not true. Because it's got a minus, that coefficient is actually -2.5. So, at least think about rewriting subtraction as the addition of a negative. Cool?
Cool.
Shahib, question?
No, I was thinking about something that
Okay.
I was confused for a second and then
Oh, I missed it.
So we're going to do the first one here together. Then you guys are going to fill out the rest of the table on your own. In my first expression here, Lily, how many terms do I have?
1.
So we've got a 12a minus a 3.
Aren't terms variables?
Terms are not just variables. Terms are any different values in the expression. So we have a variable value and we have a constant value. We really have two. You gotta count the constants as part of your terms. Then this is not number of coefficients, it's what are the coefficients. So Nate, do you know what my coefficient or coefficients are there?
Is three?
3
No.
is part of the constant. It does not have a letter with it or a variable with it, so it's not a coefficient.
Okay, so that means 12.
12 is our only coefficient here. And then our constant term, James.
3.
Karen, help him out.
Oh.
-3. When there's a minus in front of the value, it goes with the value. So we could rewrite this as 12a plus a -3, which is what I was just showing you on that last slide, and yet you already forgot. So that's the trap door. Guys, I've had people come to me very, very frustrated. They're like, I swear I'm typing in the right answer and it keeps telling me I'm wrong. They're really mad at digits, and all I do is I point to the minus, and then they think for a second and they face palm and they walk away. And then they finish their homework, realizing that if they paid attention to begin with, it would have been easier. So try the next 3 on your own. If you have any issues, stick up a hand. I would be glad to help you. What? Yeah, you can see my desk.
Constant. Hold up. Give me a sec.
None at all. You can't be next because you can't see.
Yeah. I'm blind. Hold up. Constant term.
Constant has to not have a variable involved. To be a constant, it has to not be connected by multiplication to a variable. There.
Constant can be a variable. No, it can't.
Question or answer? You're right. No, you either put none, or I'm going to show you what symbol is used for the empty set. But check your variables. You have a slight mistake, a very minute mistake. This seems so weird. You're going to need to only have 3 desks.
Maybe it's 8.
Well, not the y's don't involve the variable. When you're listing the coefficients, you don't involve the variable. So, Miss Bowers, how many terms are in this next expression? 3. We have an x term, a y term, and a z term. Now, what are my coefficients here? You want to move on or you want to do it? Noah, what are my coefficients? So coefficients are any numbers that multiply by a variable. So what's the multiplier for x,
So it
Noah?
would be the 0.2 and the 8.1.
The 2/10 and the 8.1. Close. -1. This coefficient in front of your y is a -1.
Oh. That makes sense now.
What are my constants, Seth? You need to phone a friend because you left our class at a very inopportune time.
I don't think there is any.
There are none. So you would either write none. Somebody in the last class made the argument we could put 0 because you could say that there's a +0 out here that isn't doing anything. Or, anyone know the symbol for the empty set? What you use when there is no answer that exists? I expect that you would probably know it. Only because Noah's dad teaches me.
Is it I?
No. That's the imaginary number. Baylor?
I'm not sure, but
You're thinking phi and it's not.
No, not phi, omega.
Thinking about this?
No, I was the 0 with a line through it.
Yeah, it's that. Which I don't remember if that's actually omega or not. I don't think it is. I'm pretty sure omega is like
That's omega.
that.
That's alpha.
That's omega.
This is omega with at least capital. This is omega.
Yeah.
Trust me, because my wife's sorority was Kappa Phi Omega. I know her letters, so that's omega.
Did she know your letters?
Yeah. So, Zach,
Got a quiz on that.
how many terms do I have in this next expression?
2.
Constant term,
Shit.
variable term, variable term. We count all of them. I think you're only counting the variable terms. This is a term, this is a term, and that's a term. So we really have 3. Does that make sense now, or are you still confused? Hey, can we stop the chatter? It's really getting frustrating. Because I need to hear Zach. Zach, what's your confusion?
You said that in a very,
So if you go back up and look at your notes, variables are terms and constants are terms. They're all terms. So coefficients here. Okay, sure.
Okay, coefficients are 9 and negative 6.
9 and negative 6. If you only put 6, it's wrong. Ashton, what is my constant? 7. And Jackson, bring us all back home. How many terms?
1,
What's coefficient?
3/4.
Constant? Excuse me.
0.
None. What? I'm sorry. Well, your card will come up. Your card will come up tomorrow.
That was big. That also messes.
You know you liked it. Actually, I think it's still part 1. Try the got it on your own. You need to write out and identify how many terms. So you could put number of terms. You need to identify your coefficients. You could abbreviate COEF if you want, or it's fun to spell, so you could write out the whole thing.
I don't think it's very fun to spell. I don't think it's fun to spell.
Well, that comes back to your attitude.
I'm just kidding. I love spelling. Spelling's my best friend.
98%.
Yeah, you're only at 98.
Spelling is my best percent.
Alright, turns. We have 1, 2. Wait, can it be negative?
Constant be negative.
You can add a negative, but a positive value cannot be a negative value.
Yeah.
I don't know what you're exactly asking. Hopefully the answer figures
That's
itself
what I
out.
got. Okay.
Karen, how many terms do we have up here? 4. Now some people get confused by the fact that we have a P, a C, and a PC. What did we say yesterday about when we had 2 variables together?
It's one. Oh, sorry.
Right?
It creates, it's like, it comes together and it's like one variable.
It's essentially a new variable. So we've got a variable term with P, variable term with C, and a variable term with PC, which is essentially its own thing. Pranav, what are my coefficients in this expression?
The coefficient
Yep.
would be 6p.
No, P. You do not involve the variable. When we're talking about coefficients, we're only talking about the number in front of the variable.
6, then -7,
-7
then 9.
and 9.
I want to do constants.
Ella, constant. -4.
Yeah.
Told your card will come up.
Hopefully,
Questions? No?
no.
Go to the back. Actually, I'm going to let this play out in digits. So when we look at simplifying expressions, we can use the commutative property. Who can remind us what the commutative property tells us? Commutative property. Commutative property. Shaib. What do you mean switching?
Swap, like, if you swap the numbers, it'll like still stay good. Give you the same value.
We can change the order without changing the value. Essentially what Shaib just said. Zach?
One place to another. How I remember it is you commute to school every day.
Yeah.
Because you're moving from your house.
Yep. When you commute, you're moving.
But
So,
you stay the same.
here's what we do when we have an expression that we're given.
Negative 5 times x and 11 times x are like terms.
Sorry, if you're watching the video, you probably hear both right now.
4 and negative 9 are like terms.
So, first thing you do is say, well, can I solve inside these parentheses? Can you add negative 5x and 4 together? No. Can you subtract 9 from an 11x? No. So, those parentheses really aren't doing anything. So, we then regroup our like terms. So, and this is, I think, what you're going to need to write on your paper. You don't have lots of room. Oh, no, I showed it for you. So, we are applying the commutative and the associative property. What's associative property?
You can use the commutative and associative properties of addition to move the terms around and group the like terms.
Yeah, it's what is associated with each other. So, to begin with, the negative 5x and the 4 were associated because the parentheses, the way that you can kind of remember it, is the first 3 letters of the associative property. Have I talked about this yet? Look like butt cheeks. So parentheses associate things. So
It's a male donkey.
So we regroup. We say negative 5x goes with the 11x. The 4 goes with the negative 9. The sign in front of the number has to go with it. So notice, I had a negative in front of my 5 here. I still have to keep that negative in front of the 5. I had a negative in front of my 9 here. It had to go with my 9. Then once I've regrouped, and on your paper it shows the whole process out, we can then use our...
To combine the
factoring
like
to
variable
factor
terms,
out
use
the
the
x,
distributive property
because it's
to
common,
factor out the
and
variable
then
part.
combine my values, negative
Then
5 plus
simplify.
11, that'll bring me positive. Again, different signs, you find the difference. So then 4 plus a negative 9, the difference between them is 5, but the negative is more powerful. So we get a negative 5, and we simplify writing it by just 6x minus 5. Does that make sense?
Maybe. Makes dollars.
There's no money associated. It's funny. He sounds like Bree.
So we'll do this first one together, then I'll do the next 2 on your own. We want to regroup. So I like to do the variables first. So if you had a highlighter, here would be a very good time to use that highlighter. 2r, negative 5r, I'm going to put those together. And I'm even going to put them in parentheses to make my life easier.
I'll let you use them.
The 7, does the 7 have a like term? Nope, the 7 is all alone. So lonely.
It's okay.
So then 2r minus, hey guys, simmer down. You need to have your own highlighters. They were on your supply list. 2r minus 5r gives me what as a sum? 2 minus 5. Okay. Negative 3, because the negative is more powerful. So I get negative 3r. And then the 7 was all alone, so it's still just plus 7. Try the next 2 on your own. Show the regrouping to put your like terms together. Be careful that you take the signs with the values. And then solve. Simplify. There's always, so saying you can put is kind of, I'm trying to figure out what the best phrasing is. The 1 is always there. We just don't see it. So when we can show the 1.
Alright.
Is there questions over here?
I have a question.
Real questions?
Yeah. So how should we?
So that's really like a 1R, right?
Yeah.
So you're going to have 1R and then a negative 3R or minus 3R. You could write it as plus the negative, or you could just write minus. As long as you take that sign with it.
I don't think I got this right. I think I filled it.
Right. And that's what we talked about when I said I don't say 1 shaheed, I just say shaheed. So saying the 1 would be redundant. Yeah, it's mathematicians like to be as efficient as possible. Why we don't always show that 1 in front. So I don't know why you're goofing off and talking about like internet things when you haven't solved these. Need help or you okay? So remember, this is really a 1R. So when we regroup, we're going to have that 1R minus 3R. And I would put those together in parentheses.
So that's
And then we'll have plus 4, because it's positive, minus 11. So I would open a parentheses and put all my R's in there, then close that parentheses. Put an addition, open a new parentheses, do my constants, and then close that parentheses. So give it a shot.
Dude, help me.
You can work to the right. You seem like you were trying to keep it all real tight there. As tribute. We have a couple more cards to get through, so I want to make sure everyone gets a chance. So Carrie, can you talk to me about what regrouping and reordering or whatever you did on the second expression here? So this is a really good strategy. Carrie, at least how you're saying it to me, said the negative 3R first, and then plus R, which we actually know is plus 1R, so I'm going to go ahead and show that. You don't have to keep them in the order they're shown. So if you want to put the negative first, put the negative first. It's simpler for your brain to think about, I'm at negative 3 and I go up 1. I'm now at negative 2. So then what'd you do, Carrie?
And then I added the 4 minus 11.
Yeah, so then we had 4 minus 11, or you could write negative 11 plus 4, or you could write 4 plus a negative 11. Lots of ways we can show this. So we already said my R's are going to become negative 2R. What do I get when I combine my constants? What is it? Negative 7, so we could either write plus negative 7, or we could just write minus 7. Questions on that one?
Wait, if you do plus negative 7, do you have to have it in
Yeah, then you have to put your, because you can't just have a plus minus. There has to be a parentheses. Yeah. It gets too messy mathematically. And the other reason we do that, Zach, especially, is because we use this symbol to mean add and subtract. So there's a quadratic formula that is like b squared minus 4. And there's a step in there. It's actually negative b squared plus or minus radical 4ac. So there's 2 solutions. This one, and there's more to it. But there's actually 2 solutions in using that formula because it goes with graphing a parabola. I know I'm going really far. So when you graph a parabola, it looks like this. And there's 2 solution points, 1 positive, 1 negative. So that's why we can't write plus minus without a parentheses to break it up. So there's the tangent for your lesson today. But also a tangent is a line that's against a circle.
That's what our teacher
Yeah.
said last time.
That's what Calvin was singing. That's really funny.
Who's next? Rye. Thought you were gonna miss out. What's the first thing you had to do in this expression?
I put the things together, so negative AR and R. Oh shoot. Oh.
What's the first thing you have to do, Rye?
Not do what I just did.
What's the first thing we should do?
Uh,
When there's a number right up against parentheses,
It's multiplication.
yeah,
it's multiplication, but because there's two terms inside the parentheses, what property is it?
distributed.
Distributive property. So the first thing we actually have to do here
Oh great, thanks.
is distribute. So we then get 5r plus 5
Okay.
for that actual first set of terms, and then plus the negative 8r, oh crap, plus 2.
I done goofed.
You gotta pay careful attention. Olivia, what'd you do next?
I grouped the 5R and the 8R, the negative 8R.
And you could either write plus a negative or just write it as subtraction. And then, Leah, what's the other grouping that I have here? We already took my variable terms, so what constant terms do we have? Talking to Leah. Sorry, I can't hear you. 5 from this one, and then 2 from our other one. So then when I go to simplify, 5r minus 8r gives me... You have an objection. What's your objection?
So the 5 on the outside of the parentheses, wouldn't that be multiplying all of it? All of in the parentheses?
Yes, we did. 5 times the r gave me 5r. 5 times the 1 gave me 5. Yep. I agree with what you're saying, but it's not really an objection. So, Grace, what'd you get in the end here? Plus 5r. Now, this is why sometimes I like to think about this as plus the negative. Because when we think about it like that, we see that they're different terms. What's the difference between 5 and 8? 3, right? So, because the negative is more powerful, we get negative 3r. And then the 5 and the 2, we get 7. So negative 3r plus 7 should be what we get there. Questions?
I just messed up in the entire problem.
Pranav?
When I wrote the plus, I mistook the plus for T.
Ah, yeah. You got to be careful that you know what you're writing and can read your own handwriting. Some of you guys have that issue. You can't read your own handwriting. Yeah, I mean, there's always a few ways that you can do it. If you got the same answer, that's fine. So now the got it we're going to do together, because I want to show you guys a nice mental trick for checking when you have problems like this. It says, what expressions will be equivalent to negative 6 plus 5t? So I know all I have is one variable term and one constant term. If I look at my constant term, negative 6, I can look at what, Pranav, you with me? I can look at what will the sum of the constant terms be and determine if it's even plausible. So I have a constant of 13 and a constant of 7. When I were to combine those, what would I get? 20. There's no way I can get negative 6 if I have 20. So we know that 1 is right out. It is gone. As soon as we look at the constants, it's no longer an option. Now here, we'd want to do the distribution. So 5 times negative 2 gives me negative 10, plus 5 times t gives me 5t, plus 4. So now look at your constants. We have a negative 10 and a positive 4. Will that give us negative 6? Yeah, so we'll come back to that and check the variables in a second. Down here, I have 9 and a negative 15, or a minus 15. Will that give you a negative 6? Yeah, so that one checks out. Then here, well, this distribution would be 2t minus 6. So I really have a negative 6, a 3, and a negative 1. So if I combine my negatives, I have negative 7 plus 3. Will that give me negative 6? No. So option 4 is out. So now we only have 2 options left. Now go look at your variables. Variable I need to be is 5t. So 5t, any other variables? No, so this checks out. It works. And down here we have 4t and a t. Did we get 5t? Yeah, so it also works. Try this next example on your own for a second. I want to see who can reason through what it actually means when we say that the what is it? That the width is, or sorry, that the length is 9 feet longer than the width. And then we want to solve perimeter. So give that a shot. The length is 9 feet longer. We know to find perimeter, it's 2 times the length and 2 times the width because there's 2 lengths that are identical and 2 widths that are identical.
I wondered why I had all these extra pieces. I totally forgot about the bench I was going to put in. Well, back to work.
She was just talking about making a flower bed. She was like, I'm going to build a box for my garden. Which I have garden boxes kind of like that. And actually, I think this situation is almost identical to what I have in my backyard. Because the length, no, it wouldn't be 9 feet longer. Close, though. The next problem is probably more similar to my flower box, or my planter boxes for my garden.
So if I was you,
I'd start with what is the length, what is the width. Perimeter is always, for a rectangle, 2L plus 2W. Perimeter for a rectangle is always going to be 2 lengths and 2 widths because they're the same. Like the length is the same as the length, the width is the same as the width.
It isn't a width.
Yeah, it is.
No, never mind.
A rectangular frame for a flower bed.
Did you just hear?
Rectangular. All right, we're starting to run out of time. Who thinks they know how to tell me what the width and what the length can be? We'll just go hands now. Karen? Hold on. So if I come over here, you're right, but I want to come over here first. So the width, they tell me the width is W. So then what did you use for the length?
9 plus W.
I agree, but I'm going to write it W plus 9 just because I like to put my variables first. There's no, yours is right. I just like the variables first. So then, Karen, you were saying you talked about the perimeter as being 2 times.
9 plus W.
Yep.
10 plus W.
2W. Be careful to keep that 2 there. Then we have to do the distribution. Two times W is 2W. 2 times 9. And then we have another 2W at the end. Then I can, Olivia?
No, I don't know. But I figured I made it very much simpler. But I don't know if it
But is it going to be expressed in terms of only W?
yes.
So hold on. Yeah, you have to only use W.
I only use W and 9 and 2.
Oh, well that's okay. Like you can use numbers, but it's saying the only variable you use is W. So hang on to it for a second. You'll probably get the same answer we got. Zach, what can I do here now?
Would you add the W's?
I add my like terms. I have 2W and another 2W, so I really have 4W. And then I add 18 with that. Now I have 1 more minute left. I know you all want to pack up, but I legitimately, in the schedule, have 1 more minute. So, the got it, if it tells you that the width is half the length. This is actually pretty much identical to my gardens. if the width is half the length, now I know the length is just the length, and the width is half the length. But now when I set up my formula for perimeter, 2W plus 2L, well, 2 times half of L, what's 2 times a half? Or half of 2. That's just 1. So we get 1L plus 2 more L's, and this perimeter becomes 3L. That is all we have for today. Your homework is already posted. Have a wonderful rest of your day.